Here's something that should genuinely bother you. We have particle accelerators. We have supercomputers. We have nanotechnology, artificial intelligence, and the ability to land a robot on Mars with pinpoint accuracy. And yet right now, in universities and research labs all over the world, actual scientists with PhDs and multi-million-dollar equipment are staring at objects made by ancient civilizations and saying, out loud, in professional settings, we do not know how they did this. Not, we have a rough idea. Not, we think maybe. We genuinely do not know. We're talking about a 2,000-year-old analog computer, more sophisticated than anything built for the next 14 centuries. A medieval sword containing nanotechnology we only discovered in 1991, a concrete formula from ancient Rome that self-heals and has outlasted everything we build today by a factor of about 40. So let's talk about the ancient technology that absolutely should not exist. 1901. Greek sponge divers are pulling artifacts from a shipwreck off the island of Antikythera. The ship went down around 65 BC. They're finding statues, pottery, the usual haul. Then they bring up what looks like a corroded lump of bronze. Nobody's excited about it. Gets thrown in a box, sits in a museum for months. Then an archaeologist notices the lump has cracked open. Inside, dozens of interlocking bronze gears, precision cut, perfectly arranged, in a device that is over 2,000 years old. What they had pulled out of the ocean was a fully functional analog computer. This single device could predict solar and lunar eclipses, track the positions of the 5 known planets, calculate the dates of the Olympic Games, and model the irregular orbit of the moon, which requires advanced mathematics we would not formally develop for another 1,000 years. After this thing was built, humanity would not create anything mechanically comparable for 14 centuries. Scientists have spent over a century studying this object with X-rays, CT scans, and 3D modeling. They know what it does. They mostly know how it works, but recreating the precision of those gears with modern equipment has proven extraordinarily difficult. Here's the part that should really get you. It was found in a shipwreck, being transported somewhere. Which means this was not some bizarre one-off miracle built by a single genius. Someone was shipping these, casually, across the Mediterranean, like cargo. How many existed? How many are at the bottom of the ocean right now? Nobody knows, and that question is going to live in your head for a while. Sometime in the early Middle Ages, swordsmiths in the Middle East started producing blades that made everything else look like a stick. Damascus steel. Blades that could split a falling silk scarf clean in half the fabric's own weight, enough to divide it. Blades that cut through European swords like they were made of soft cheese. On the surface, these distinctive swirling water patterns. Not decoration, a byproduct of the forging process itself. A signal that something unusual was happening inside the metal. Fast forward to 2006. Scientists at a German university put fragments of a genuine Damascus blade under an electron microscope. They found carbon nanotubes inside the metal. Carbon nanotubes, cylindrical structures of carbon atoms arranged at the molecular level that are among the strongest materials known to modern science. Materials we use in cutting-edge aerospace and medical technology. We officially discovered carbon nanotubes in 1991. Medieval blacksmiths were forging them into swords 800 years before that. Here's where it gets humbling. Nobody can replicate it. The technique was lost around 1750 when the specific ore deposits used in production ran out. Blacksmiths have been attempting to recreate genuine Damascus steel ever since. Some have come close. Nobody has matched the originals in both structure and performance. We can build particle accelerators. We can sequence the human genome. We cannot make a sword as good as some guy in a 12th century workshop. Sit with that. The Pantheon in Rome was completed in 125 AD. It contains the largest unreinforced concrete dome in the world. It is still standing. Right now. You can visit it today. Meanwhile, modern concrete, the stuff we build highways and parking garages and entire cities with, starts seriously degrading after about 50 years. We pour literal billions into concrete maintenance every single year because the material we make today is dramatically inferior to what Romans were mixing by hand 2,000 years ago. For centuries, nobody could figure out why Roman concrete was so much more durable. The recipe was known: volcanic ash, seawater, lime, but the results were inexplicable. Then, in 2023, scientists at MIT finally cracked part of the mystery. Roman concrete contains tiny white chunks of lime, called limeclasts, that were previously assumed to be manufacturing imperfections, mixing errors, sloppy work. They are not imperfections. When cracks form and water seeps in, these limeclasts dissolve and recrystallize, filling in the damage automatically. Roman concrete self-heals. The material literally repairs itself when exposed to water. Seawater, which destroys modern concrete, makes Roman concrete stronger. Whether this was deliberate engineering or an accidental discovery that Romans simply observed worked, we don't know. Either answer is remarkable. Either they engineered self-healing material 2 millennia ago, or they noticed it worked and kept using it without knowing why, which is somehow even more impressive. Modern engineers are currently trying to reverse engineer this formula for construction today. Mass production has proven extremely difficult. The specific volcanic ash the Romans used has chemical properties that are hard to replicate. The Pantheon just sits there in Rome, completely unbothered, quietly making every modern building look embarrassing. We're not done. The Baghdad battery. Around 250 BC, someone in Mesopotamia assembled a clay jar with a copper cylinder and iron rod inside. Fill it with vinegar, you get 1.1 volts of electricity. Alessandro Volta wouldn't invent the battery for another 1,800 years. The design is suspiciously specific for something being called a storage vessel. You don't accidentally assemble copper, iron, and electrolyte in that exact configuration. The Lycurgus cup, a Roman glass cup from the 4th century AD that appears green in reflected light and blood red when lit from behind. Scientists analyzed the glass and found gold and silver nanoparticles embedded inside at 50 nanometers in diameter. Deliberate nanotechnology. In a drinking cup, from ancient Rome. The color change phenomenon it exploits wasn't scientifically understood until the 20th century. The walls of Sacsayhuaman, a fortress in the Andes built from limestone blocks weighing up to 130 tons each. They fit together so precisely, a piece of paper cannot be slid between them. No mortar, no cement. Just stone interlocking like a 3D puzzle. The structure has survived 500 years of earthquakes in one of the most seismically active regions on Earth. We have no solid explanation for how they cut these stones with the tools they had, let alone moved 130-ton blocks up a mountain. Pumapunku, a temple complex in Bolivia at 12,800 feet altitude, containing H-shaped stone blocks with surfaces accurate to fractions of a millimeter. Fill holes completely uniform in diameter. Interlocking pieces with the precision of manufactured components, all carved from andesite and diorite, two of the hardest stones on Earth, by a civilization with no iron tools. Modern engineers have said they'd struggle to replicate this work with today's equipment. Here's what connects all of these. Every single one of them was made by people who are consistently underestimated by history. Civilizations we casually label as primitive, while standing next to the ruins of things we cannot rebuild. The Antikythera mechanism was on a cargo ship. Damascus steel was commercially traded across the medieval world. Roman concrete was poured into harbors and aqueducts by construction workers doing a job. These weren't miracles or flukes. They were technologies developed, refined, used, and then lost. Sometimes because trade routes shifted. Sometimes because the people who knew how to do it died and didn't write it down, which raises the question nobody can answer. How much more is gone? How many discoveries were made and then forgotten? How many techniques existed, worked brilliantly for centuries, and then vanished without a trace? We don't know. And that's the part that should keep you up at night. Because if a corroded lump of bronze pulled from a shipwreck in 1901 turned out to be a 2,000-year-old computer, what else have we walked past? What's sitting in a storage room somewhere right now that we haven't looked at closely enough? Which one of these broke your brain the most? Drop it in the comments. I'm genuinely curious whether it's the nanotechnology swords or the self-healing concrete that gets people the most. If you want more history that makes you question everything you learned in school, subscribe. We've got a lot more where this came from.